Humans don't live in isolation. And if you are going to deploy your app somewhere, there is a high likelihood that there was already an app running before you came. And it's important to move data from these older applications, even if they are highly unstructured, into your new application. So in this video, I want to take you through some general principles, tips and tricks, and tools that I have personally used and we at MedBlocks use quite often to just walk you through how you can do this yourself. So this process is generally called ETL, extract, transform, and load. And in each of this step, we'll take a look at what to be aware of and how we can avoid certain common mistakes. So first, we'll talk about the extract phase. So this is you getting data from an existing application, the legacy application or the legacy database. You are trying to pull data from this existing application. So when it comes to extract phase, it's very important to know the constraints that you're working with. Is this going to be an ongoing synchronization? Is the legacy system going to run parallelly with your new system, or is this going to be a one-time thing where you just get a database dump and you're good to go? So these things are very important to consider because the principles that I'm going to explain is mostly for continuous replication. So if it's just a one-time extract, it's much easier. You can just do it once and get it over with. But if it's a continuous process, then the parts that are going to come next are going to be very helpful. It's also important to understand the level of support that you can get from the previous team. So sometimes they can make changes in their application to accommodate you, but sometimes they can't. Sometimes they don't have access to the team. So it's important to know in advance the level of support you will get before you start looking and architecting the extract phase. So it's always a good idea to go with something like a message broker in the middle. So whatever you do, putting this message broker in the middle, make sure that you don't have to do this again, right? So for example, let's say today you have a new application and you have a new database that you're migrating it to. For example, let's say that's a FHIR database and you are moving from a MySQL database, right? So tomorrow there might be something else that comes up and you don't want to make changes to your extract phase just because something new is on the market, right? So it's always a good practice to extract and put it on a sort of a broker, a message queue. So Kafka is a very good solution for this. There are also other message queues which you can use. So what should we be aware of in the extract phase? So there is this problem called the dual write problem, and I'll just explain it to you quickly here. So let's say that you have an application and you are talking that this application is only responsible for posting, let's say, X-ray investigations. So it just posts to the database that this patient needs an X-ray. And your new application comes along and it's responsible for billing. Okay, it's responsible for billing patients for this X-ray that needs to be taken. So there is a high chance, in fact, it's not that high, but Murphy's law, if things can go wrong, it will probably go wrong. So there is a chance that the application writes, to the database, but does not communicate to you, or it communicates to the message broker, but does not commit it in the database. So this can happen for a variety of reasons. One of it being that the network is not perfect, or there might just be a case where the app crashes in the middle. So suppose you send the message out first and the app crashes, you lose the record in the database. So now, for example, you have billed the patient for an X-ray, but there is no X-ray in the database and the patient will never get an X-ray done. So that is something that you want to avoid. You can also switch this out. Like you can say, okay, then why can't I just commit to the database first and then send a message? Same problem again. Like what if you commit to the database and there is an error or there is a validation issue, something happens, and then you don't send the message. I think this is worse, right? In which case you somehow commit to the database and all that is fine. but before you send the message, your app crashes, right? So this can also happen, and this is worse because you want to make sure that your message is delivered at least once. So we want to make sure of the fact that that's possible. So now if this happens, then you lose out on the revenue. You don't bill the patient, right? So there are some smart people who usually ask, okay, why can't I start a database transaction, send the message, then commit in the database, right? So if you're using a RDBMS, so again, like, what if your app crashes right before committing to the database? That's still, this problem is called the dual write problem. It's well studied, and the solution to this is don't do it twice. And this is actually not even possible if the application developers are not ready to directly push data from their application, right? So it's always a good idea to not rely on the application to push data. Instead, the solution to the dual write problem is you commit to the database, and then you use the write ahead logs. So almost all databases have this, Postgres, MySQL, even MongoDB, and there are a lot of tools that are available to connect directly to databases and look at their write ahead logs and then push that to a message broker. So the advantage of this is, one, you don't need to make changes in your application. It can just run as it is. You don't need to touch the app. And two, these connectors are also not something that you have to build. There are amazing libraries like Debezium out there that do a wonderful job at doing this. And three, you avoid the dual writes problem. So in case the you have this connector that occasionally sets these offsets, and it stores them in a file, or you can store them on Kafka, you can store them anywhere. But basically, if the app crashes, we are okay, because like there is nothing that's committed to the database. And there is also the possibility that the connector might crash. But if it does, we know that it will come back on and it will continue from this offset that it has committed, right? So there is a slight possibility for your data to be duplicated again, because the connector might send a message to the broker, and then before committing the offset, it might crash. So in that case, you might have certain messages sent multiple times, but we'll look at ways to tackle this situation. So there is also another problem that usually comes up with this, which is, what if the data that you want to write to your database is different from the data that you want to send to the message broker? So in this case, it's usually a good practice to do something like the outbox pattern. And this is from microservices.io. So again, you have to make changes to the original app here, but your original application inserts both the original table and the outbox table that needs to be sent out in one single transaction. And your message relay or your connector, like Debezium, listens to this particular outbox table and then pushes that to a message broker like Kafka, right? So that's about that's the main thing that you need to know about the extract part of things. In fact, that's the most difficult part. Once you have the extract part, the other challenges, there are challenges, but they are relatively simple. So I will just show you a practical demo and walk you through the transform and load process. Okay, so let's get into it. So the main thing is, in transform, you want to maintain idempotency. So since idempotent is where you do an operation multiple number of times, but the results are the same. So suppose you have a green button and a red button, and pressing the green button turns something on, and pressing the red button turns something off. Pressing the green button multiple times still keeps the machine on, right? So that's idempotency, and we'll see how we can do that. So let me walk you through how we've implemented this using Apache Nifi. So let me quickly log in here. And so the original database here. So again, let me just quickly port forward. I'm again running all of this on Kubernetes. So yeah, let's just port forward this MySQL database that I have. It's just a sample database. So I'm just going to connect to that real quick and show you how it looks like. So this is a patient table. Okay, so we have a bunch of rows representing patients, and there are a lot of patients. There are like more than 100,000 patients in here. So what we want to do is we want to extract all of this data and put it in a message queue, and we want to do it with that at least once semantics, right? So I've used a tool called Debezium. Okay, and most of this is, again, like, it's running on Kubernetes, and I can show you if you are more interested, but I think you'll be able to figure this out yourself. Debezium has a connector for almost all popular databases: MySQL, MongoDB, Postgres. Just check their documentation and you'll be able to figure out how to do this for your particular database. But yeah, you get your database, you connect it through Debezium, and right now I'm pushing it to a Kafka topic. Okay, so how that looks like is, again, let's go into this particular Kafka topic. There are a lot of topics, but this particular one will be called, let me just search Aarti. Yeah, so it'll be called Aarti SQL patients, and you can see that there are 155,000 records in there already, right? So that's all of the patients. They are coming out as messages here. Okay, so this is what Debezium does first is it takes a snapshot. Okay, so when you connect it for the first time, it takes a complete snapshot of the table and it outputs all of these messages for every single row in the database. And then you make any changes to the database. So for example, let's say that I'm just in live mode. So this will just show me the latest changes that are occurring now. So I just changed something. Let's just say I changed Nishta to Siddharth, right? So let me save that. And you can see that immediately triggers it triggers a message. So I have changed Mr. Nishta, which is before, to Mr. Siddharth, that's after. Okay, so you can quickly get these messages on a message queue. So now the next thing what you need to do is you need to read this message queue, right? So again, this is using Nifi. We are running a consume Kafka process. So again, Nifi is basically an ETL pipeline tool that you can use. So what we are doing is we are reading all of these records. So let me just start this. It will read almost everything. I'm going to list this queue and see what we have. So we have, whenever we read from Nifi, we don't usually just get one patient record. We get like thousands, right? So when I search for, I think it doesn't do it properly in the formatted. But when I search for patient ID, there is 77 in this one. And it depends on its mood, basically, how many there are. But usually there are up to 1,000 plus records that might be present. And this is important, right? This is really important because when you're doing processing, you should always do it in bulk and you should always do it in batches. You should not split this into individual records and then do it one by one. So now you can see that reading MySQL Kafka, we've got like 207 records, right? Each of these records might have anywhere from 77 to 1,000 different patients. So now then what we are doing is we are doing a Python transform. Okay, so we are just using a command, just Python migrations/Kafka FHIR.py. I'm going to show you how this file looks like. Okay, let me just quickly show it you on GitHub. Medblocks/migrations. Again, now this is not really open source, but I just want to show you how the script looks like. So let's just take a look at the script. So it's a very generic Python script, but what it does is it takes in the data that's coming in, from MySQL, and then it looks for certain things. It does some cleaning up, and then finally what it does is it outputs a FHIR resource. Okay, it actually outputs this thing where it has a put method and the URL and then the resource. So this will come in handy because we are going to actually post a bulk FHIR resource and post like multiple patients together. Now here, what you need to notice is that we are actually doing a put request and we are not doing a post request. The reason is because we need to maintain idempotency. So no matter how many times I run this particular flow file, how many times I run this sequence, I will get the same results in my FHIR server. Okay, so that's the main takeaway here. You need to make sure that this is idempotent. So the way we do that is we take one of the attributes from the database, like patient ID, and hash that using UUID5. So that means given one patient ID, you will always get the same UUID every single time. Okay, we are doing that for the patient URL, and we are also doing that for the patient's actual ID. Okay, so we are doing all of this, and we are kind of generating a patient resource. I just want to show you how it looks like. Let's just run this once, and there's already 19 queued, but we'll see once this finishes, there will be 20. Yep, there's 20. And let's just take a look at this. See, you have your nice patient resource, and there is only one right now because this probably only has one. But some of the bigger ones will have like a lot combined, right? So you have a bunch of FHIR resources together, and all of these FHIR resources have like a ID that's derived from the patient ID. So it's always going to be a put request. It's always going to be idempotent. You're not going to have duplicate patients in the FHIR server. Okay. So then we are just kind of doing a lot of these split records. So in fact, I can confidently run this. Although this is in production, I can confidently run all of this because everything is idempotent, right? So I'm just splitting this into batches of 250. So usually I get like 1,000 records together. So I want to split this into batches of 250 because it's easier to post batches of 250 to a FHIR server. It handles it a little better. So now we have all of this. And we have also transformed this a little bit. So this is just a jolt transformation that's happening here. What we are doing is we are just adding this resource type bundle and type transaction. That's it. Like everything else stays the same as how it came from the Python script. And then finally we have invoke HTTP. Okay, so invoke HTTP actually makes a request. So here we are making a post request to this particular URL, and all of the failure cases go here. Till now, none of them have failed. So I'm just going to start invoke HTTP, right? I'm going to show you how a successful request looks like. So let's just wait for a few seconds, and it should start processing this, and we should see it in this queue. Yep, we got our first one. So this, again, like Nifi can only show JSON, and for some reason FHIR returns application/FHIR. So if you take a look at this, the content type is application FHIR plus JSON. So yeah, this update attribute basically just updates the attribute so that we can view that. So let's check it out here, and you see that we have a bunch of different patients all saying 200 okay, 200 okay, because they already exist in the system. We've already created them, and we've already run this migration before, so that always exists in the system. So this is how you would run a migration for the first time. So I'm just going to stop all of this, and I'm going to empty all queues. Okay, so this is okay because we are storing everything in Kafka, right? So it's always present, and you can read it at any time you want. So you can just go to this particular topic, and it will always be there. You can read from, for example, from earliest. If you start reading, you will always get the older records as well. So now I just want to change gears a little bit and show you how this also maintains consistency later with an ongoing synchronization as they are using the old system. So you have, for example, let's say we have the latest right now, right? So we've applied that. So again, everything has stopped, but let's just start everything. Okay, we've started everything. So now what we should see is as soon as we make a change here, we should see that reflect in this flow. Okay, not sure how long it will take. We have a few success conditions here. But let's see, let's take one particular patient, let's say MedBlocks. Okay, let's just call this hello there, and then I'm going to save that. So that should result in our Kafka reading another topic and it going through. And let's see here, it's already done. It's already finished that, and we have a success here. Let's take a look at this. And yeah, this is this particular patient, and it has updated immediately. So let's just see how that looks like. Yeah, so we have this, and you can see that the name changed to unknown. Okay, so let's see what has happened. So that's because I put two names in the first name. It just expects one name, I suppose. So let's change it to just good, right? So our Nifi process will again, like, it'll listen to the whole thing, and we've got one more, right? It's the same thing. So let me just refresh this, and we've got good Ramesh, right? So again, in the transformation, this was not expected when putting two values in first name to fail, but we should have probably handled that a little better. And it's important to handle validation and checks in the transformation function. Okay, so that's just a good lesson for me too, I guess. But yeah, so as we change things here, so let's just do for YouTube, right? YouTube Ramesh. So as soon as I do that, when I refresh this, we get a change here, right? And that's real-time synchronization between a database and our own FHIR server. So hopefully that was helpful, and that helped you get an idea about how to split things and how to do things. And I'll see you in the next one.